When you first see the number 6 over 2, odds are you see that first as a fraction, but it also represents division. That 6 on top represents the total amount that you have, and in this case, we're going to divide it into 2. So I can represent that on my screen by adding 6 tiles. And I would like to move them into 2 different groups. So I'm going to select 3 of them and move them into 2 different groups. Notice that each of the groups now is equivalent to my original expression on the page. And that's because each group has 3. And if we work backwards, 2 groups of 3 does equal 6. Let's apply this to something a little different. Now we have negative 6 over 2, which means I start with negative 6 and I'm going to put it in 2 groups. Let's do that, starting with negative 6. And now I'm going to put this into 2 groups. So I'm going to select these and split them into 2 groups. And now that I've split them into 2 groups, each group has 3. And this time, my value is going to be negative 3. Notice on the page, everything is color-coded in red. That's because all of these representations are equivalent. This one looks pretty straightforward. 6 divided by negative 2. Let's see what that looks like. I start with 6, and now I'm going to divide it into negative 2, but that doesn't make sense. I want you to think back when we multiplied. What happened when we multiplied negative 2 times 3? That is the same situation here. This time I have 6 groups, and I'm going to divide it into the opposite of 2 groups. So the opposite of 2 groups means I'm going to take these 3 right here and move them into their own group, but I'm going to take the opposite of them. When I do that, notice the screen is now color-coded all the same, and again, my result is negative 3. Well, isn't that interesting? Now I have negative 6 divided by negative 2. The same principle applies. I have 6 negative integers, 1, 2, 3, 4, 5, and 6. And just like the previous example, I'm going to divide it into the opposite of 2 groups. So place it into 2 groups and take the opposite. So now my value, let's check it. My value is 3. Thinking back to the rules that we developed when we multiplied integers, what patterns did you notice here, and what rules can you develop from that?